same everywhere. I think it's also true, the converse is also true, although that's less clear. Okay, anyway, what is the explanation for these two particular functions for why they should have the same derivative? Oh, well, just duh, right? Secant squared x just is tan squared x plus 1. That's just the Pythagorean identity. So, in fact, what we could have just said about f and g is that f just actually is, secant squared, is just g plus 1. And so from that perspective, of course they have the same derivative. They're just one apart from each other. Okay, 3 problems to go, 153. This just says, determine the points in the interval at which the graph of, so here's this function, 2 cosine x plus sine 2x has a horizontal tangent line. Alright, so this is barely calculus. I'm given this function, I want to know when does it have a horizontal tangent line. Well, that's just basically saying when is the derivative 0. So let's take the derivative. What is the derivative of this function? Well, the derivative of cosine is negative sine. So that's 2, negative 2 sine x. And the derivative of sine 2x, the derivative of sine of something is cosine something back inside for the derivative of 2x, which is 2. Okay, and so just immediately now I want to know when is this 0, and so I just need to now solve this equation, 2 sine x plus 2 cosine 2x equals 0. And this is like, the calculus is over in one step, but the pre-calculus is significant here. This is a sort of a medium difficulty level pre-calculus problem. How do we solve equations like this? You learned stuff like this in pre-calc B. Well, okay, first of all, I can maybe just divide by 2 just to simplify things a little bit. So we get 2 cosine x minus sine x equals 0. How do I solve this equation? Well, here's where you try to convert this into sines, and you can do that, right? There's a rule for cosine 2x. It's 1 minus 2 sine squared x, and therefore I've now reduced this down to an equation that is quadratic in sine x. Okay, so distributing through by, multiplying through by a negative, just cause, that gives me 2 sine x plus sine x minus 1. And now I hope that this factors, and I bet it just does, right? Yeah, I don't even need these stupid things. It's just gotta work. There aren't too many options. So it's 2 sine x, 1 sine x, 1, 2 sine squared, and then that would be plus 2 minus 1. So there you have it. And so the answer is that this is 2 sine x when this equals 1 or when sine x is negative 1. And so, a lot of pre-calc going on here. When is sine a half? Sine is half here and here. In other words, and I think it actually just said do it on the interval 0 to 2 pi. I think it said. So that's going to be pi over 6, 5 pi over 6. Those numbers have sine 1/2. And sine is negative 1 at 3 pi over 2. Okay. Shot. Good. Boom. 2 more problems to go. 154 is basically the exact same thing, I think. Alright, so this is a lot of practice. By the time you're done with this homework, you should just be getting really good at the chain rule. And getting all just back into things. So 154, determine the points which is the graph of x over root 2x minus 1 has a horizontal tangent line. And so once again, we're basically just being asked to differentiate this function instead equal to 0. Okay, let's go. so, yeah, what should we do here? I think we should do the product rule. I could do the quotient rule here, but just notice that this function is really just x times 2x minus 1 to the negative a half. And to me, it just seems easier to write it that way, so I have fewer fractions to deal with. Okay, let's go. Okay, so differentiating, what do you get? Derivative of the first, which is 1, times the second. So I get 2x minus 1 to the negative 1/2, plus the first, x, times the derivative of this. Okay, so how do I differentiate 2x minus 1 to the negative 1/2? Well, something to the negative 1/2 is negative 1/2 something to the negative 3/2. Okay, so what does that give me? It gives me 2x minus 1 to the negative 1/2, and now, oh, I forgot the chain rule. Back inside 2. Let me just double check that I did this right. Derivative of the first times second plus the first times the derivative of something to the negative 1/2 is negative 1/2 something to the negative 3/2 back inside of the derivative of 2x minus 1, which is 2. So I did screw up the chain rule there. But anyway, now I caught my mistake. So 2 times negative 1/2, those cancel. And so I'm just going to get negative x 2x minus 1 to the negative 3/2. Alright, and this is a good opportunity to pause and say, if all I wanted to do was to take the derivative, then I would just stop here with this ugly mess. But seeing as how this problem requires me to now do something algebraically with this derivative, namely I want to set it equal to 0, it seems like a good idea to simplify this now. And if we simplify this now, there's a little algebra move, which, okay, here we go. So there's something that you've been doing since, algebra 1 that you've never really even been thinking about it. If you have something of the form a squared plus a to the 7th, and you want to factor it, well, just naturally, you factor out a squared, and then you're left with 1 plus a to the 5th. So there you have it. There it is. Okay, now, if you wanted to be weird or something like that, you could factor out, so the rule seems to be, factor out that one. Well, what is that one? It's the one with the lower power. 2 is less than 7. If you wanted to be strange and factor out a to the 7th, well, it wouldn't be wrong, it would just be weird. You would get this. Now, that's not wrong, but it's not pretty either, where I define pretty as, getting rid of negative exponents. So if the goal is to write your final answer with no negative exponents, then it seems like the thing we should do is to factor out the lower power. Well, okay, well that same thing applies when you have a mix of positive and negative exponents. So, or just all negative exponents. So if I give you now a to the negative 2 plus a to the negative 7th, and I want to, factor this, the simplest thing to do is just still factor out the one of the lower power. Negative 7 is less than negative 2, and so if I just factor out a to the negative 7, then I'm left with, well, negative 7 times a to the negative 7 times a to the what is a to the negative 2? It's going to be 5 by exponent rules, plus 1. And thus this is a to the 5th plus 1 over a to the 7th. And that's just nice, because the negative exponents are all gone. Alright, so over here, when it comes to simplifying this, to make some sense of this, I could just convert this into a big mess of disgusting radicals and stuff like that, but instead, let me factor out 2x minus 1 to the negative 3/2, because negative 3/2 is less than negative 1/2. And now magically, things are going to be beautiful, because I'm going to be left with some number of 2x minus 1s. How many? Well, 2x minus 1 to the negative 3/2 times 2x minus 1 to the what gives you 2x minus 1 to the negative 1/2. Answer 1. So boom. And then this is just minus x. So this is a kind of an advanced algebra move, but once you get used to it, it's very efficient to simplify these kind of disgusting things over here. And so, what do I have now? I have that my derivative is really just x minus 1 over 2x minus 1 to the 3/2. And all of that work, which was mostly algebra, only a little bit of calculus, I now see that there's only one time that there is a horizontal tangent line. It's when x is 1. 1 minute. Hi, you're on the video.
I need to get the baby awake.
All right. Good. Do you want to be on camera or do you want me to stop? Why don't you just wait 1 minute? All right. Woo. Actually, I'm just not going to do 172 because I don't feel like it, so I'm going to be done in 1 second. F prime of 1 is clearly 0. That's the only time this is 0. And so F has a horizontal tangent. Oh, the baby is awake. At x equals 1. And was that the question? Yeah. Okay, good. I have done all but the last problem, which I don't feel like doing because I have to draw a graph and I don't want to. Alright, that was the homework that was due on the last day of school. Hopefully you did all of it and this was mildly helpful. I will be making more videos soon. Goodbye.